Hi guys, today we're going to learn about cylindrical coordinates. So, how do we define points in two dimensions with polar coordinates? Well, what you were doing back in pre-calculus, it was finding r and theta, okay? So the cylindrical coordinate system is an extension of polar coordinates in the plane to the third dimensional space. If we want to define points in three dimensions using the concept of polar coordinates, we will call this, instead of polar, cylindrical coordinates. So what's this? In a cylindrical coordinate system, we have a point P in the space, and it's represented for another triple, r, theta, and z. Okay? So r and theta are the same old friends that you have from pre-calculus. Okay? So this is going to be the polar representation of the projection of P in the xy plane. Z is going to be the directed distance from the point r, theta, to P. Okay? To convert from rectangular to cylindrical coordinates, or vice versa, we're going to use the following conversion guidelines. Okay? So from cylindrical to rectangular, you are going to use your old best friends, okay, from polars. X is equal to r cosine theta, and y is equal to r sine of theta. And guess what? The z is just going to be z, okay? So that's what you have, okay? So from rectangular to cylindrical, again, similar to pre-calculus, you are going to have that it's going to be x squared plus y squared is equal to r squared. And tangent theta is going to be equal to y over x. Z, guess what, is going to be z, okay? So please remember that the point 0, 0, 0, okay? So 0, 0, 0, we call it the pole, okay? It's called, okay, the pole, okay? So you know, FYI, okay? In case that we call it another way, you know that is going to be the point 0, 0, 0. Okay, so let's do some examples here so you can see that it's actually pretty simple. Okay, so you have the point 1, 1, 1. Okay, so find the coordinates of the point in cylindrical coordinates. So what are you going to do? What you recognize here is what we have here is x, y, z. Okay, so that's what they are telling you. They are telling you that technically you have rectangular coordinates, okay, the equivalent of rectangular coordinates in 2D. So what do you have? To find r squared, you know that it's going to be x squared plus y squared. Okay, so this is going to be what? Okay, you know that this is going to be 2, therefore r is going to be what? The square root of 2. Why positive? Because it's, you know, it's a distance. Okay, so it needs to be positive. After that, what you're going to do here is you're going to find tangent theta, right? Tangent theta, you know that y over x is 1 over 1, which is just 1. So you know that theta is going to be equal to tangent inverse of 1, which you know that this is part of the unit circle. Okay, so you know that it's going to be pi over 4. Okay, and please remember that theta needs to be in between 0 and pi. Okay, so that's going to be your theta. So we have all the pieces of the puzzle. R, theta, and now you're going to tell me, so what's z? Z, we know that z is 1, right, from the hypothesis of the problem. Thus, what are your cylindrical coordinates? So we have that in cylindrical coordinates, coordinates, you have that your new point is going to be root 2, comma, pi over 4, comma 1. Okay, so that's what you have. Isn't that nice? What do you think? Okay, so let's move on to more examples so you can see that it's actually pretty simple. Okay, so identify the following equations. You can have r is equal to 2. Okay, so what do you have there? Let's say that you don't see it. Okay, do you agree that back in pre-calculus you were squaring both to see what was the business here? So you have that this is r squared is equal to 4. What is r squared? R squared is going to be x squared plus y squared is equal to 4. So what do you have here? In 2D you have that it's a circle, but now that we're in 3D you recognize that this is a cylinder. Okay, that's what we have. Do you agree with that? Now, the next one that we have over here, what do you have here? Well, technically speaking, this r squared, you know that it's going to be what? X squared plus y squared plus the z squared that you have, that it's equal to what? 100. So what do you have that it's the situation? This is a sphere. Okay, so you can see that it's a sphere. Why all of them are positive? They have the same, basically, coefficient. Okay, and you know that the radius of the sphere is root 100, which is 10. Okay. Now you're going to tell me, what are we going to do with this one? Well, since you don't see anything, well, the r squared can give you something. So I square both sides. So you have z squared is equal to r squared. Okay, then what do you have here? You have that z squared stays as z, but r squared, what's that? X squared plus y squared. Do you agree with that? Now, let's say that you're like, I don't see it. Okay, so move all your stuff to one side. So you have 0 is equal to x squared plus y squared minus z squared. What do you have there? Since one of them is negative and they have the same coefficient, you do know that this is going to be a cone. Okay, and that's what we have. Okay, what do you think? It's not that bad, right? Now, for this example, you need to write the equation of a parabola with opening along the z-axis in cylindrical form. So what are we going to do here? Well, the first thing, you follow the idea that it's along the z-axis, so it's going to be z is going to be equal to x squared plus y squared. Okay? Then what are you going to do? They want it in cylindrical form, so this is rectangular form, or whatever you want to call that. So this is going to be z is going to be equal to r squared. Do you agree with that? Therefore, your conclusion here in cylindrical form, okay, is going to be z is equal to r squared. Okay, and that's it. So, for this example, they tell you write the equation of a plane with norm -1, 3, 2 at the point 1, 0, -1 in cylindrical coordinates. So, what are you going to do here? Well, this is going to be the norm. So, technically speaking, this is A, B, C, and then you have a point. So, what's the plane that we have? Okay, so the plane is going to be -1 parentheses x minus something, okay, plus 3y minus something, and then plus 2z minus something is equal to 0. Do you agree with that? Now, what's the something? A point. Do you have a point? Yes, they are giving you the point. So -1, then you have minus 0 if you want, and then plus 1. Okay, so that's going to be your equation. Then you distribute, okay, you solve it, so you have -x plus 3y plus 2z, okay, and then you have that this is 2 and this one is +1, move it to the other side, so you have that this is -3, okay, so that's what we have. Cool. Now, what are you going to do here? Okay, if we want it in cylindrical coordinates, clearly you have x's, y's, and z's. The z is fine, but the one that you need to fix is the x and the y. We know, okay, from the formulas that what was x, r cosine theta. So you have -r cosine theta, and then plus 3, and then you have r sine of theta, and then you have plus 2z equals -3. Okay? Yes? Now, you can take out r as a common factor, okay, as you were doing this in precalculus. So you have negative cos theta plus 3 sine theta, okay. Then this one was not affected by the r, so leave it alone, okay. You can even move it to the other side, so you have a situation like this. Let me do it so you can see how clean is this one. This is going to be -3 minus 2z, and then what are you going to do? Pass this dividing. Do you agree with that? So what do you have that it's r? You have that r, let's write it here. Your r is going to be equal to -3 minus 2z divided by what? Negative cos theta plus 3 sine theta. Okay, isn't that nice? So that's going to be your expression. So you need to solve for r when you have a situation. So this is going to be your in cylindrical, okay, coordinates. Okay, yes. Okay, do you see it? So it's not that bad, right? Okay, so you solve for r. Okay, here I'm going to put solve for r, so you know what to do. Okay, so the next one that we have over here, okay, they are telling you that theta is pi over 4. Write the equation in rectangular form. So you have an angle, so you know that tangent theta is equal to y over x. Do you agree with that? So in this equation, what do you have? You have tangent of pi over 4. Do you agree with that? And that is equal to y over x. Okay, what's tangent of pi over 4? You know your unit circle, it's 1 is equal to y over x. And then what happens here? Thus, okay, what's going to be your equation? You solve for y, so y is equal to, surprise, surprise, x, okay, in rectangular form. Isn't that beautiful? Look at that. Okay, it's the equation of a line. So for this example, you need to write the equation of y is equal to 1 over root 3x in cylindrical form. So what are we going to do for this one? Well, what you can see is you can pass the x dividing to the other side, and you have something like this. Y divided by x is equal to 1 over root 3. Okay? So from that, what are you going to do? We can rationalize. Okay? So if you want, so it's neat, and you can see that you have an old friend here. So here, okay, you can recognize that what you have here, okay, is going to be root 3 over 3, okay? So what do you have here? You have that then theta is going to be equal to tangent inverse of what? Root 3 over 3, okay? And you know that this is from the unit circle. You know that it's pi over 6. So guess what? Thus, you can see that theta is going to be equal to pi over 6, and that's going to be what? Your cylindrical form, and we are done. Isn't that simple? Well, I hope that you find this video helpful. If you have any questions, please remember to write them in the comments, and I'll see you later. Bye.